Good afternoon, distinguished guests, esteemed faculty members, and the students of RVCE and Prayoga. My name is Mrida Pradhan, and I am a student in my third year in the Department of Computer Science and Engineering, Data Science, and I will be your host for today. Before we begin this session, I would like to request our principal, Dr. K.N. Subramanya, to escort the following dignitaries onto the stage. Firstly, we have Professor Jeffrey D. Ullman. Next, I also invite Dr. K.S. Nagabhushana onto the stage. Next, I would like to invite Dr. H.S. Nagaraja onto the stage. I would also like to invite Dr. M.P. Shyam onto the stage as well. Finally, I would like to invite Shri D.N. Prahlad onto the stage. We welcome you all. Every once in a while, we have the opportunity to stand in the presence of a pioneer who has not just witnessed the digital revolution, but authored its foundational chapters. Today is one of those days. We are gathered here at RV College of Engineering for a technical session in conversation with Professor Jeffrey D. Ullman. To the students here, Professor Ullman is the man whose textbooks have shaped the very curriculum that you all study today. From the foundational works on databases and automata to a textbook of compilers that's so iconic that it's literally referred to as the Dragon Book, we are truly in the presence of a legend today. As a Turing Award recipient, he holds what is widely considered to be the Nobel Prize of Computing. Today, we explore the next frontier, AI and its impact on your future programming careers. To officially set the stage for this afternoon of learning and transformation, I invite Dr. K.S. Nagabhushana, Director of Research at Prayoga, to deliver the welcome address.
Good afternoon. It's my absolute pleasure to be providing the welcome address, where we have Professor Jeffrey D. Ullman, the Stanford University professor, ex-professor of Stanford University, and the person who created the gradient platform along with his colleagues, which Prayoga is now taking to a different level by having the root question method, which will be utilized for the students belonging to 9th to 12th grade to learn mathematics in a non-fearful environment, and a platform being developed in consultation with the team of Professor Jeffrey D. Ullman, an Alan Turing Award winner, an equivalent of the Nobel Prize. It is my absolute pleasure to invite him for this function. Thank you very much for gracing this occasion. We are going to hear him in association with Dr. K.N. Subramanya, the principal of RVCE, for a fireside chat on AI and its impact on programming careers. It will be a very fruitful and an eye-opener for most of us who revere him as one of the doyens of computer science. And RVCA is going to witness this.
We just welcome them with the bouquets.
I now request a colleague of the RVCE to welcome Professor Jeffrey D. Ullman to this function. The connect to both RVCE and Prayoga for Professor Jeffrey D. Ullman was made possible by Sri D. N. Praladji, the founder of the Surya Software Systems, and a person who was in the Yester Infosys group. We welcome you. The person who enabled all these things are the president of the RV Trust, Dr. M.P. Shyam. We welcome you, sir, to this event and for presiding the. It's my turn to introduce Dr. H.S. Nagaraja. Most of you know BASE in Bangalore on Bull Temple Road. That was one of the initiation of Dr. H.S. Nagaraja. He is the founding member and the chief mentor of Prayoga, which today is helping 11,500 students to learn science experientially across the state of Karnataka, which involves 96 government schools and 16 private schools. And programs like Anveshana, Prerana, and other thematic areas of research are performed at Prayoga. Dr. HSN, we welcome you to this event. And I request Dr. K.N. Subramanya to welcome him to the gathering. Principal SN, you're going to. And the person who is responsible to get all of you with the right messaging and then the kind of intensity of the discussion that is going to happen is Dr. K.N. Subramanya, the principal of the RVCE. We welcome Subramanya ji. उद्यमेन हि सिद्ध्यन्ति कार्याणि न मनोरथैः न हि सुप्तस्य सिंहस्य प्रविशन्ति मुखे मृगाः. Being industrious is one of the major requirements for all of us, and I think that will be the essence of the discussion that is going to happen in the fireside discussion that is going to happen with the moderation by Dr. K.N. Subramanya and a student of RVCE, Sumukha Upadhyaya. And I welcome all the dignitaries, the lecturers and the faculty members of RVCE, the student community and the members of the Prayoga family, the journalists who have come and gathered and the special invitees. I welcome all of you to this wonderful event and I wish success to this interactive session that is yet to unfold. Thank you very much for your presence. Welcome to one another.
Before we conclude the welcome note, we would also like to welcome Dr. K.S. Nagabhushana himself with a bouquet. Thank you so much. Thank you, sir, for setting the tone for this session. This event is a collaborative effort aimed at transforming how we learn. To share the vision behind this initiative, I would like to call upon Dr. H.S. Nagaraja, the founder and chief mentor of Prayoga, for his address.
Good afternoon, everyone. Professor Ullman, Dr. Shyam, Dr. Prahlad, Dr. Nagabhushana, Dr. Subramanya, and all the professional colleagues, invitees, press people, and my student friends. This is a very special occasion for us. It's not easy, and it's a sort of blessing that we have somebody like Professor Ullman being with us for the whole day. Since 8:15, he has been with us relentlessly, not taking a minute's sort of rest. Sir, your presence has made us experience something which we should all learn at your age, and tirelessly spending time with students and professionals. Once again, with his permission, I would like to present a brief picture of why I am standing here. I represent an organization called Prayoga, which is a young organization which is about 10-year-old. The organization, as my colleague Dr. Nagarkrishna already said, is involved in education research. It's primarily an education research organization with about 170 people working for the organization, and it has its campus on Kanakpura Road. It's about 35 minutes journey from here. The basic idea of starting this is to see that the way learning happens or education happens in this country happens very different from what it is as of now. We are all part of this system. It's not complaining, but understanding facts. Most of us learned most things in our school and college career by rote memory. There is a curriculum, things are defined, examination patterns are defined, the number of questions in each chapter are well known, and we game the system and we get marks. But education is not that. Education is far beyond that. Anything that does not stimulate thinking, that does not take us to things beyond information is no education. So, the trustees and the Prayoga faculty thought that we should do something beyond rote memory, and the best way we thought, and which most people agree, is experiential learning. Anything that is not experience is only information, and that has no place. And that too in a modern world like this, where we know the technology changes and the artificial intelligence and so on. Man who created these objects may become a slave for these objects one day. And therefore education has to change. With this idea of creating the right methodologies for learning right from school level, Prayoga embarked on converting the content of the school curriculum, because anything we do outside of the curriculum is not acceptable. Where is the time? So Prayoga converted the entire curriculum of the NCERT from class 6 to class 10 into an experiential mode. Each child observes, hypothesizes, then explores through experiments, collects data, makes one's own conclusions, and those conclusions should be the Boyle's law, the Charles law, the Newton's laws. That is the model with which Prayoga has been functioning. This is not just aimed at converting or transforming the content to another mode, but it's working on collecting lot of data to understand how children learn and what are those skills and competencies that are supposed to be acquired. Because degrees or certificates don't take us anywhere. Therefore, the modules are so designed that children's abilities, which build up over a period, like maybe right from observation to seriation skills or computational skills or problem solving skills, these are all tested through a lot of data. The organization collects about 2,500 to 3,000 data points about each child per year. And this goes on for 5 years. It's a longitudinal study. And about roughly 13,000 data points are present about each child. And the project envisages studying about 30,000 children from urban, rural, semi-urban, including tribal children. And this data, when properly interpreted, should be able to help the policymakers on how the future education in this country is supposed to happen. We have started with science and mathematics to start as a beginning, but we are extending the studies to cover all other domains so that the totality of education is covered. And therefore, Prayoga wants to become a globally important organization in the context of India to help evolve the future educational policies. That's one of the objectives. One other important project on which Prayoga is working, this first project is called Kriya, Kriya is action, so it's active learning. The other program is called Anveshana. Generally, we get into research say beyond our post-graduation. Of late, we find undergraduates like in engineering and science colleges doing some projects and publishing results. But even then, the average age may be about 20, 22, 23, and much of the formative age is lost. If we are stuck to rote memory kind of thing for too long, we are so hardwired, we can't really do divergent thinking or out-of-box thinking. Keeping this in mind and using the formative age, if we can give a clear lead of 6, 7 years or 8 years for a student to become a researcher, probably the nation would benefit with better researchers. Keeping this, the Anveshana program has been designed. In this program, we have completed 3 editions, and in the first 4 editions, in the first 3 editions, we did some 20 projects. They are all children from end of 8th to 9th, 10th, 11th, 12th. Most of them are 9th and 10th. We had completed about 20 projects. 11 publications have happened in international peer-reviewed journals by high school students. In fact, this only demonstrates that if we can adopt this method, the students, not only engineering college people get, we often hear people right from ISC saying, we are not getting bright students, we are not getting children who are really capable of divergent thinking. So we are actually trying to build a base for higher education to be better and the future thought leaders for this country. In addition, we have quite a few other projects, and we are a team of about 170. The average age of the organizational manpower is about 28. So it's a young, vibrant organization. I thank RV people to join hands with us for this exercise. And incidentally, I'm also happy to say that I have been associated with RV in some way or the other for the last 30, 35 years from the days of Mr. D.A. Pandu. So I thank the RV management for joining hands on this occasion, and let us celebrate the lecture of, a short lecture by Professor Ullman, and probably more interaction by our young friends. Thank you very much.
Thank you so much, Dr. Nagaraja. Prayoga's motto of research to transform learning is really the backbone of today's session, and it's incredibly aptly put. Now, RVCE has long been at the forefront of technical excellence in India. So I would now like to invite Dr. M.P. Shyam, President of the Rashtriya Shikshana Samiti Trust, to address the gathering on behalf of RVCE.
Good afternoon, everyone. Professor Ullman, Dr. H.S. Nagaraja, Dr. K.S. Nagabhushana, Sri D.N. Prahalada, Sri K.N. Subramanya, faculty members from various RV institutions, my young students, and members of the Prayoga family. I would like to say a few things about RV today. RV Educational Institutions is also known as the Rashtriya Vidyalaya Institutions. It's a distinguished educational group based in Bangalore, established in the year 1940 by Sri M.C. Shivananda Sharma, a freedom fighter, educator, and a Gandhian thinker. RV Educational Institutions was founded with the vision of making quality education accessible to all sections of society. From its very modest beginnings, the institution has grown for over more than 8 decades into a comprehensive educational ecosystem. Today, the RV Educational Institutions encompasses over 30 institutions serving more than 32,000 children across various academic levels, from school education to higher professional studies. The group is managed by the Rashtriya Shikshana Samiti Trust, a non-profit organization committed to the founder's philosophy of education with societal commitment. Guided by the motto, "Go change the world," RV Educational Institutions aims to develop learners who are academically accomplished, ethically grounded, and socially responsible. A key milestone in RV Educational Institutions expansion is the establishment of RV University, a UGC recognized state private university offering multidisciplinary programs across liberal arts, sciences, business, design, law, and computational fields. Through academic excellence and strong community engagement, RV Education Institutions continues to nurture future-ready leaders committed to societal progress. I would now like to say a little bit about RV College of Engineering. RV College of Engineering was established in 1963. It is one of India's earliest self-financing engineering institutions. Managed by the Rashtriya Shikshana Samiti Trust, RVCE was founded with the vision of delivering high-quality technical education aligned with societal needs and industry expectations. The institution began with 3 core disciplines: civil, mechanical, and electrical engineering, and has grown since over the last 6 decades into a comprehensive center for engineering education, research, and innovation. RVCE is an autonomous institution affiliated with VTU, Belgavi, offering 13 undergraduate and 13 postgraduate programs, along with PhD research opportunities across several departments. Academic autonomy granted for undergraduate programs in 2007 and postgraduate programs in 2016 enables RVCE to implement industry-relevant curriculum based on outcome-based education, emphasizing experiential and project-based learning. The institution is accredited and ranked by NAAC, NBA, and NIRF multiple times. RVCE actively promotes research and industry collaboration through 21 centers of excellence and 6 centers of competence, supported by leading industries such as Tata Motors, Tata Technologies, Mercedes-Benz, Bosch, Rexroth, and others. With strong international collaborations, a vibrant student ecosystem, and a consistent placement performance involving 225 companies, RVCE continues to be a premier destination for engineering education in India. Once again, I welcome all the guests and all of you for this prestigious event. Thank you very much.
Thank you, sir, for that address and for hosting such a monumental exchange of ideas here at RVCE. Before we begin our main event, we are honored to have a special address from an industry visionary. Please join me in welcoming Shri D. N. Prahlad, founder of the Surya Software Systems Private Limited, to share his perspective with us.
Good afternoon to everyone. I would like to ask students some questions. When was AI first started? What year do you reckon, or at least what period? Can someone? 1961. Excellent. So it's not new, right? It has not taken away any jobs. I mean, I had a good job for a long time and still do. So how many of you have used cursor? What have you used it for? Learning? Oh, come on. Don't give me politically right answers, please. I'm from the industry. I'm not grading you. I can only give jobs. I don't grade people. Whoever has used it, please tell me why you used it. Somebody. You have so many hands. Yeah.
So to automate tasks, the ideas which come, we can quickly use it to get. Like we think of an idea, we just write, I want to create such app, it creates it automatically.
Creates what automatically?
The app, it writes the
Okay.
code for us.
Right. So you use it for programming.
Yes.
Okay. Now you're going to hear in a few minutes from Jeffrey Ullman. You can ask him questions. Professor will answer you on what his vision of AI and jobs will be. Are you all worried about AI and jobs? No? No? Seriously? You think AI is not going to take away your jobs? What gives you that confidence? I'm worried.
Just studying IML.
No, someone else please. Come on guys. Come on, somebody answer.
stage of ideation up to the writing of unit test cases, it can handle everything.
So why do you have a programming job? Your senior can do that job.
Yes, sir, but then the number of jobs will come down as well.
So you fear loss of jobs. Anyone else fears loss of jobs? Yeah, your reason?
The same is it's very fast and a lot of times it captures ideas that I wouldn't have gotten myself.
Okay.
So I feel like the intellect is being taken over by AI.
Okay. How many of you will think the jobs will shift to another kind of job? Okay, what does it shift to? Somebody, please. No, not you. You answered. Your turn is over. Someone else. I'm sorry to curb your enthusiasm, but...
So can you hear me?
Yeah.
So I think, from a more, hardcore programming perspective, right? With AI coming into the jobs, like what the change we're going to see is that us humans are going to focus more on the design aspect. We'll be focusing on what we can do best, that is come up with solutions. And it doesn't have to just be, writing code. It's like coming up with like how are you going to solve, how are you going to use AI to solve XYZ. It's about the thinking. Like I feel that's where the jobs are going to be oriented towards.
Excellent. I think that is what the discussion, we have given a preview into the discussion that's going to happen. I have different views. Professor has different views. Everybody and his uncle has a different view, including my uncle. So let's discuss. Let's have some fun. And over to Professor Subramanya and Ullman.
Thank you, sir, for lighting up the crowd and telling us about your uncle. So, we now reach the heart of our program, which is the reason we are all here today. This fireside chat aims to address the questions on every student's mind. Is AI a tool, a collaborator, or a competitor? How do we maintain intellectual rigor in a world of automated code? And perhaps more simply put, this is a question I've actually heard from my own juniors. What should we learn, or maybe why should we learn, when AI can code so much better than us? Joining us for this deep dive is our guest of honor, Professor Jeffrey D. Ullman, Stanford University Professor Emeritus and Turing Awardee. Now, moderating this session are two individuals representing two facets of the technical realm. Firstly, we have Dr. K.N. Subramanya, our principal, who brings the perspective of academic rigor and curriculum evolution. And next, we have Sumukha Upadhyaya, a second-year student from the Information Science and Engineering Department, representing the curiosity, anxieties, and high energy of the next generation of engineers. The floor is now yours.
Okay, namaste to all of you. Good afternoon. Very happy to be here to talk to Ullman. I think if you look into his age, many in this hall were not born actually. So I think he has such an experience in the area of whole field of computer science. And sometimes it is very difficult to ask questions for a person like him. But I assume myself as a learner in the field of computer science. I am sure that we can learn a lot from him. And we were just looking into it. Majority of the people who are in the computer science here would have read all the books that have been written by him. Very fantastic books he has written. And hope we'll get something out of him today from his experience, from his heart. We would like to ask certain questions because as you know that Turing Award is supposed to be one of the biggest awards any computer scientist can get. So I think he is a Turing Awardee. So I would like to ask the first questions to Professor Ullman, that can you tell the whole journey? I think it has taken a long journey for you to reach to that stage. I'd like to say the important milestones you have achieved before you got the Turing Award. So that's the first question.
Well, let's see. Not as much of a journey as you might imagine. I think I was probably around 28 when AO and I did the thing that we were awarded the Turing Award for, and then 50 years elapsed, and then they gave us the award. The idea that we had, which is, it was a way to basically make parsing an important part of a compiler an easy thing to do, and this led to the YAC Unix command, which actually Steve Johnson designed, not AO and I. But for about 40 years, it was the way to design a parser. Okay. I also have a sneaking suspicion that they really just wanted to have an excuse to give us both the award, not to waste 2 Turing Awards on us. And really the thing we did was the books. And if there is if there's a journey, it's just, you write one book. Don Knuth once said, nobody ever writes 2 books. Okay, either you write one book and it's such an ugly experience that you never write another one, or you get the hang of it and then you just churn them out one after another. Like anything else, you get the hang of something once you practice it enough. And that really, in a sense, has been my journey, is learning to write books to the point where I can write a book about a subject I know nothing about. And in fact, have done that many times. Anyway, so that's sort of the story, I guess.
Professor Ullman, continuing on the discussion that we were having earlier, many students are anxious that AI can now write standard algorithms instantly. In that world, what is the core role of a computer scientist? Are we builders, or are we increasingly judges of correctness and reasoning?
I think still builders, and I think we're talking about software engineers, right? Look, for many years you've been able to implement standard algorithms by using a Python library or a Java library or an R library. There's nothing really new about that. There is no question, but I think we're going to be talking a lot this afternoon about vibe coding. That is the process where you prompt an LLM to generate code, and then you prompt another LLM to debug that code or check its correctness. Okay, I'm spinning my mental wheels again. The creative process it still has to be there. Someone has to say, not only what is worth writing code about, or what application is worth doing, but at least roughly how to do it. And I say it's only roughly. It's always been only roughly. We start off when you program in a machine language or assembly language, you're saying something very precise about what you want to happen. When you program in a higher level language, you don't know quite what's going to happen. You just have a rough idea. If you write A equals B plus C plus D, somehow B, C, and D are going to get added, but you don't know exactly in what order or where that's going to happen. Similarly, when you use a library or use a very high-level language like SQL, you have really very little idea of what exactly will happen, but you know what you want the outcome to be. And I think vibe coding is just another stage in a continuing process that we've been going through.
It's very insightful.
Yeah, actually, as you know that you have been a great teacher, and we would like to know from you, because the curriculum, if you look into now, the kind of changes which are happening in the field. So we would like to know what should be the balance between the fundamental knowledge to be taught to the students, because some of these things are available now, and what would be the application part for a 4-year degree program. So how could we balance this kind of a knowledge versus the application part?
Okay, well, again, the fundamental idea, you still need to know the fundamental ideas. That includes, for example, models. Let's talk about parsing. As I said, for a long time, YAC was the way to parse. Maybe, I don't know, sometime between 10 and 20 years ago, you had a library. Now, if you want to parse, or you write, you just call the parse method in Java or many other languages, and it does it for you. But you still have to know what parsing means, okay? And you have to have some sort of a picture of what's going to happen to the stuff that you're parsing. Okay, so that hasn't gone away, and I don't think it is. It's going to go away. The one thing that's different is an education for in computer science is going to change in a small but significant way. Okay, I think it's still necessary to teach people how to write code. So you're going to have a first course in, Java programming or Python or C++ or whatever your faculty prefers. But you're going to write the code yourself, and as in, I assume, most courses, you will be forbidden to allow an LLM to do your job for you, just as you're forbidden from allowing your smarter older sister from writing your code for you. But the new thing is someplace in the curriculum, probably by the sophomore or junior year, you're going to have a course in vibe programming. And the way I see it is now, instead of being forbidden from using an LLM, you are forbidden from writing code yourself. Okay, the course would presumably assign problems of some sort, much as the introductory programming course does, but you'd have to get the code by prompting one LLM to write it for you, and another one to debug it for you. Okay, probably not a good idea to use the same LLM. Okay, but other than that, I don't really see big changes at this point. No.
Thank you.
You often tell the Lego server story. So early on, building systems meant dealing directly with limits in hardware and resources. Today, many of those limits are hidden essentially from us. By abstracting away those constraints, are we losing the deep system intuition that made innovations like Google possible in the first place?
Okay. By the way, does everyone know the Lego story? Does anyone know the Lego story? It's, when Larry and Sergey had developed Google, they had to actually demonstrate that it works, and they therefore needed what was in those days a lot of disk. Excuse me. They actually had a half a terabyte. So does your cell phone today, but that's another story. But that it was, when you had the biggest disks were like 8 gigs. You needed, just many disks to get up to have what is it, 200 and,
4 terabytes.
how many?
4 terabytes.
Yeah.
They needed 4 terabytes.
well, they needed as much as they could get, but what we gave them was a half a terabyte, if I recollect. Yeah. But you know, the point is, in those days you could get a lot of the web on half a terabyte. The point is, it was over 100 disks. I forget exactly how many. And that was really my contribution to Google, was buying some disk. The idea behind Google is actually very natural and and simple and pretty much independent of how much disk you own. The interesting thing is numerical analysts, when reporting on the great achievements of numerical analysis, always mention Google as an achievement. Why? Because the method that they use, the PageRank idea, can be thought of as a numerical algorithm, even though Larry and Sergey would never think of it in that way. To them it was just a computation, an algorithm, basically. Now, yes, today, if you want to have a terabyte or 4 terabytes or a petabyte, you can rent that from Amazon or a number of other places. I think that this opens up opportunities. For example, it's very hard for a single university to have a petabyte of disk. But if you really need it, you can rent it for a short time at a price that it doesn't exactly break the bank, I guess. I guess it depends on how big your bank is, but you know what I mean. It's it does open up opportunities at universities that really were not available. There's the fact that cloud computing is so available and so inexpensive. It does open up a lot of opportunities. I don't see it as a harm exactly. I think that's what's worrying you.
Yeah, about whether like when you were doing compiler design, it was a integral part that you optimize everything to meet these requirements, right? Now it is not that much of a big thing.
Well, to an extent, but look at it this way. Still today, if you can reduce the running time of the programs that a compiler generates by 0.1%, that has a huge economic impact on the entire code base of the world, right? And 1,000. If you can save 1,000th of the money that we now spend around the world on computing, you're doing something quite impressive. Okay, so so running time doesn't matter in little cases. If you're keeping a laundry list, then you want to keep it as an array instead of a linked list. No big deal. But when you're doing something big, or in the case of compiling, when you're affecting everything, a large amount of what goes on in the world, it's still, running time still important in many situations.
So in continuation with the discussion, I think we have faculty here and also the researchers. So I'd like to find out from you, what are some of the two to three areas of research which faculty could focus in the future?
Okay. Well, the obvious ones are, we haven't said the last about machine learning technology. For example, there's still a lot of work in making the generation and use of these deep learning models making them faster, making them smaller, which typically means deciding which of the parameters actually make a difference and which of them are just sitting there really doing nothing at all. A lot of interesting problems on that. The process of going from LLMs to agents, essentially, that is using the foundation model, one of the foundation models that are available, and building software that actually achieves a particular goal. For example, I'd love to have an agent that was a travel agent that could figure things out as well as I do for myself. Right? For example, on this trip to India, I actually booked tickets on 4 different airlines. Thereby optimizing my costs. I'd love to see an agent should be able to figure that out. Now there are non-AI questions. Cybersecurity and computer security, which aren't exactly the same thing, are both very important. The cybersecurity is the theory of codes, of what can be decrypted and what cannot. Computer security is a more eclectic subject where you're often using cryptography to protect certain assets. It's not just let's say access policies, but the psychology. How do you prevent your staff from falling prey to a phishing attack, for example? How do you test whether they are susceptible to certain attacks? So there's that. And I guess I'd be remiss if I didn't mention quantum computing. I happen to be kind of a skeptic on quantum, but there's no question that people are working very hard on the hardware necessary to have an actual qubit that lasts long enough to do something useful with it. It influences cryptography in important ways. The idea that probably there are methods that is something like RSA, which is, I guess, the most commonly used cryptographic system, is not what they call quantum secure, and that is, if you really had a quantum computer, you could break RSA. That doesn't mean that every cryptographic system is what could be broken by a quantum computer, and so we'd like to find one that isn't. Okay, and we'd like to do it fast. Okay.
Thank you. Given your focus on the system, if you could instantly fix one systemic flaw in engineering education, what would you fix?
I'm pretty happy with the way engineering education goes. I think if you're talking about what Gradients does, and I'm going to talk about this in I guess a couple of minutes. Gradients is designed not to change what is taught, but simply to take away some of the grubbiest parts of education, in particular grading of homework, and a little bit of coaching students who are having trouble. Okay, let me just say that. But all education suffers from, not just engineering education, but all education suffers from a lack of technology. And I'll tell you why. Okay. When an automobile company decides to put in robots to replace workers, they don't ask the workers whether the workers think that the robot could do a good enough job. Okay. When someone would like to see automation replacing faculty, the faculty have the power to say, that's not good enough for my students. Even if what they really mean is, it's not good enough for my job, right? And I'm not quite being serious, because I don't see gradients or even some of the more powerful technologies as replacing teachers. It just frees teachers up to do a better job. Okay.
That answers that.
Yeah. Actually, your teaching philosophy emphasizes on learning through failure. And so when AI comes, AI is in full force, maybe many of the low-risk things would be done by AI. So then where from these students would learn through failure?
Well, first of all, when I talked about learning from failure, I really was not thinking of education as much as research. That is, if you're doing real research, you should fail most of the time. Because if not, you're doing development. If you know you can succeed, you're just doing something, right? So you have to be prepared to fail, and you have to make something out of the failure. Usually what it means is you've tackled a problem that is too hard, but that doesn't mean every aspect of it is too hard. So maybe what you need to do is focus on a special case, or accept an algorithm that doesn't work in every case, but works in the cases that people are probably going to care about. There are lots of techniques for dealing with failure, and none of these issues, I think, do they is AI going to impact? It's going to be more, let's say, for example, your research may involve issuing prompts to an LLM to get something out of it. But your prompt may be defective, and you may fail. You get something other than what you need or want. So you have to learn to deal with it. Either you refine your prompt, or you understand that your prompt was asking for something too general, and you figure it out. Okay, so as I see it, LLMs are just one in a number of tools that researchers have used and will use, and the same failure plays the same role, I guess, that it always has.
So we have a few rapid fire questions at the end.
Which you didn't tell me about.
So if you could choose one word to describe your career, what would it be?
I don't know. Fun, I guess.
If not computer science, what field would you choose?
Well, I imagined I was a mathematician, actually. Then I discovered that mathematicians don't make nearly as much money as engineers.
One thing AI will never replace, according to you.
Sex. Although that's probably not true, is it? That was a bad answer. On several levels.
According to you, is AI a co-pilot, a collaborator, or a competitor to humankind?
Whatever it wants to be. No, seriously. I think very likely we will see it as a collaborator. I see it sort of as a grown-up Google, right? Google is a collaborator, right? When you don't know something, you just you Google it, right? It's become a verb. Pretty soon you'll ChatGPT it, and you probably are doing that already.
One paper every CS student, according to you, must read.
Good question. I mean, I might say something like Turing's and Scheiding's problem, but I never read it. I know what it says. No, I can't figure that one out.
So I think this was the initial discussion we'd like to have. Now Professor is going to tell us about, he has a PPT, some 10 minutes. Then we can have the questions from the audience.
Okay, I want to just about 15 minutes tell you a little bit about this .2 project and the technology behind the gradient system. Anyway, gradients was a system developed actually sort of right after the dot-com bust. It was the other three guys, Alan, Bagmurti, and Ramana, who they started building an education platform, and they knew I had some interest in automating education, and they asked me whether I had any ideas. And I came up with some ideas. It was actually Ramana, though, who refined them into the thing that we now offer. By the way, we do have computer science homework, so the system is free. We started off trying to make this a 4K service. Found people were willing to use it but not pay for it. So we've been running it as a hobby. We're just four guys having fun, costing each year. Okay. Do we have enough microphones on?
One more getting ready.
Okay. Let's see. So maybe if I stand here. And by the way, we do offer it. We cover a number of courses in core computer science. Anyone who wants to use it here, it is used in various places in India as well as around the world. Our largest customer, if you will, is actually the University of Cairo. Think about that. Okay, and now this is not working again. Okay, what were the problems we were trying to deal with? First of all, it was a conventional homework, by which I mean the instructor assigns some problems for students to work on. They go home, work on them, hand in the solutions a week later. A week after that, the instructor or their TAs have graded each of the homework. It doesn't scale because the work is proportional to the number of students in the class. Another thing which we notice is that homework is really a test. You're graded on it, and it's a good exercise. But in the situation where you are missing something, maybe you listened to the lecture, but you didn't. You just missed the point, and that point is necessary to solve a problem on the homework. It doesn't help you. We want it to be able to help you when you're having trouble. And then there's the fact that when you make a mistake, in this cycle it's 2 weeks in college, even if a teacher in grade school grades the homework on a 2-day cycle rather than a 2-week cycle,
by the time you get your paper back, it's too late to do anything about it, and you've moved on to something else, and you've completely forgotten about the subject of that. Okay, so what we have, I believe, is something that takes away some of the human effort, and it's, by the way, if any of you have served as a teaching assistant, you know it's the worst part of teaching. And on top of that, it helps a little bit with students who are having trouble. Okay, so this is basically what I just said. This normal hand out an assignment, collect the answers, and grade them it's too much work, and it's too long a feedback cycle. Now, multiple choice questions are easy to get to grade, and in fact can be done quite automatically. The trouble is, you can go pretty far. I mean, anybody who's taken a multiple choice test, you do what you can and then you guess the rest. Moreover, if you make a mistake, that's it. You probably never even know whether you made a mistake. You just get a number back. Now, there are systems that automatically grade student answers. It's kind of hard, especially in the situation where the answer is not a number, but no. Wait. Okay. But even if it is a number, you can express the same number in many different equivalent and correct ways. So even that's kind of hard to get all the correct versions of a number. Okay. So anyway, we developed something we call root questions, and this is what the Datu project is implementing. Okay, and our goal again is that students will, let's say, be strongly encouraged to actually work the problems, as if it were conventional homework that they have to hand in. Okay. On the other hand, the feedback is immediate. It's just associated with attempts to answer the question, and moreover, they're working on a problem and they don't get the answer. They can continue working on the same problem, just as you could, let's say, if you had a tutor, watching over your shoulder. Again, and this is, as I said, this aspect has all been automated, so it's all done by machine. Okay, so here's what it looks like from the point of view of the student. Okay, solve the equation 2x plus 3 equals 8, and then identify the true statement from the list below. Now it's a multiple choice question, or it looks that way. Now, the answer, by the way, I don't know how many have figured it out already, but the answer is x equals 2.5. Okay. Well, if you know x is 2.5, well, A is then obviously wrong, B is obviously wrong, C is obviously true, and D is obviously false. Okay, and this is really the thing that makes designing these questions tricky is you've got to get them to solve the problem and then identify something about the answer, not the answer necessarily itself, although x equals 2.5 could be one of the possible choices. But you want to make sure that that they can very quickly, if they have the right answer, they very quickly can identify from this list which of the four is correct. Okay, now suppose they make a mistake, and let's just say that they've chosen D. Well, if you think about it, okay, they're going to, when they make a mistake, they get a choice explanation. Now, in the ideal case, we kind of know what they did wrong. That's rather rare, but we might take a guess at it. I'm sorry. Yeah. Okay. So my theory is if they chose x equals 5.5, I think the way they got it is they probably kind of knew you had to move the 3 from the left side to the right side, but they might have thought you're supposed to add it rather than subtract it from 8, in which case they would reduce the question to 2x equals 11 and then x equals 5.5. So associated with the choice D, I think it's not too audacious to suggest that, to remind them, when you move a constant from one side to the other, don't forget to change the sign. Okay. Again, if there's no obvious explanation for how they arrived at an answer, we might just say, okay, I'm going to tell you how to start this. Okay. So we might say, start by moving the constant. Well, you can read it. Start by moving the constant from the left side to the right side, and then we might also just for good measure mention. Don't forget to change the sign as you do that. Now, the idea then is that they've got the hint. They've been working on this problem. 2x plus 3 equals 8, and they get another chance. Okay. The other. I'm sorry. Okay. The choices that they get, it's the same problem, but the choices they get will be different. Okay. And so this is how do we make it different? So here's how you build a root question. Again, and it's not easy. Okay, so you have the stem, as it's called. That is, you pose the question, and then you need to find several right choices. I like to have about 4 correct choices, what that means is the question that you ask has to be phrased not in exactly what's the answer, but what is the correct choice among what you see below. Okay, and that means there has to be more than one correct answer. Now, you might think, well, 2x plus 3 equals 8. There's an answer. What x is 2.5. That's all there is to it. But the choices don't have to be what is the value, the answers to the question, what is the value of x? That is, x equals 2.5 might be one of the correct choices. But you can also have another choice that is a correct property of 2.5, like like x is not an integer, or x is less than 3, that kind of thing. And then you have many wrong answers. So you have, for each one of them, you have to write a what we call a choice explanation. Okay, that may be again, if we think we know why they got that choice, we could suggest that that's their mistake. But in general, we'll just give them some sort of a hint that helps them get started. And then you probably will have to write a complete solution, which becomes available after the homework is due. Okay, so again, as I said, you don't ask what is the value of x. You say select the true statement about x. So that gives you the freedom to have many correct answers, as well as, of course, many incorrect ones. And the idea is,
you want all the work to be in the STEM, that the student does the work and then they can answer from any 4 choices as long as one is correct and the others are incorrect, by just very easily scanning the choices. Okay. Well, as I said, something like x greater than 2 or x less than 3 or x is not an integer are the kinds of things we would try in this arena. Okay, now it's a little bit more complicated than that, because even if we're allowing them to retry and we only expect them to get it right once, they can always just, let's say, adopt the strategy, I'll always answer A. Okay, and if we're randomizing, eventually A will be the correct answer, and they never have to solve the problem. Okay. First of all, there are many correct answers, many incorrect answers, so they get a different set of choices. But again, that that makes it a little bit harder, but still the strategy of I'll always choose A will eventually get them the answer. Okay. That's obvious. So what we do is we bundle questions, and I won't go into it, but I like 5 questions in a homework. And we tell them, keep working on all the problems until you get them all correct. And remember, if you have 4 out of the 5 you solved correctly, then whatever choices you're given, for the first 4 you go bing, bang, bing, bang, and you very easily answer correctly. For the 5th one, you have to either answer correctly because you finally figured it out, or you're going to get another hint if you answer wrong. Okay, so if you have 5 questions and a 1/4 chance of success for each one, your chances of being able to guess knowing nothing is about 1 in 1,000, and we think that's enough to discourage kids from using a complete random guessing strategy. Okay. So anyway, the takeaway I'd like you to get is that we think we can get kids to actually solve problems. And I was actually very pleased over at Prayoga earlier today. We actually got to talk to students, and they at least told me they did. Okay. Whether that's true or not, I don't know. And again, it gives automated help that's germane to the incorrect answer that the student has given. And again, it's a way of letting students make a mistake and yet still be able to work the problem again and eventually get it right. So, I've used this in my own classes, and about 2/3 of the students in the entire course will either get all the questions right or, maybe miss 1 out of the entire course. Okay, and of course it's all automated. If you want, you can, as an instructor, you can use our canned homeworks on a topic, or very easily make up your own homeworks from the questions that we provide. And then you just throw it over the transom and the students work on it. So it does save a lot of work. Okay, I think that's it. Yeah. Now, let's see, can we have the others? I don't know, are there any questions? Maybe we should. No.
I think let's just have one or two questions. We'll have time to talk afterwards at high tea, whatever that is.
When we are talking about the root equation, what happens if all the choices given are not exactly correct? Take the specific example of whatever the example you have taken, 2x plus 3.
Yeah.
It is a possibility that all the 4 are wrong.
Well, that's why we make sure that one is selected from the list of correct answers.
No, in this particular example, all the 4 choices can be wrong when in the C, if you consider 2 3/4.
No, I don't get it. No, I mean the way we build a root question is, the way we deliver a root question is there's always one correct answer and 3 incorrect answers.
That's what I'm saying. That whatever we are thinking as a correct answer itself can be wrong. You are saying that x is less than 3, 2 3/4 satisfied that, but that answer won't give you 2x plus 3.
Oh, I see what you mean. Yeah, you might be lucky that time, but the next time you might get x. You might get x equals x equals 2.5, or x equals or x is greater than 2 would also work. I wouldn't worry too much about it again, because if you really haven't solved the problem, there's a good chance you're not. You'll get tripped up eventually. Okay. Okay. Yeah. I mean, look. There's no question. Yeah. Sometimes you can guess, especially on one question or even 2 questions out of the 5. But you can't wing your way through everything. Okay. Yeah. Yeah. Okay. Anyway, let me. I'm sorry. All right, let's have one more question in a minute.
Whatever you mentioned, the whole root question method thing, I realized I've actually been doing it unconsciously, because I literally ask AI to explain me a lot of the subjects, right? Really, like, my question is, how did you figure out, like, learning all of this back when you were, in like 1960s or whatever, like, you've done work on parsers and compilers. Mm-hmm. I'm currently studying that for my course. I'm finding it hard with Google and with the help of, like an AI assistant to teach me all of this. I'm asking, how did you figure out all of this? Because I really want to know how you learn. I want to know the learning process behind it.
Oh, yeah, okay, interesting question.
Yeah.
But the answer actually is, your notion of all this is different for you than it was for me. Okay, there's a great deal known about programming languages now. When I was working on aspects of compiling, there was remarkably little known. Okay, I had to just read a couple. I mean, how many papers on parsing were there? Maybe 5 or 10, and that's it. Nothing else had been published on the subject. Okay, yeah, it's a different game today. I'm sort of sorry, but not really.
Professor Ullman, I have 2 small questions. One is on the language monopoly. Let's say we are all, the industry is dominated by single language like Python, for example. Mm-hmm. In future, some other language could come and monopolize. Would it lead to some kind of lock-in problems? Number 2 is, with respect to today's engineering programs, a lot of time is spent on using compiler rather than looking into construction of compilers. What would be your take on this?
Well, first, I'm not sure what you mean by use of compiler. The way you use a compiler is you run a program through it. Okay. First of all, when you talk about programming language have a monopoly, it's not exactly true. It does make for immense headaches
in that you have to maintain the compilers and the environments that are necessary to run probably, I don't know, certainly hundreds of languages today. You remember the year 2K problem? Okay, that's sort of how the companies like Infosys and then TCS got started or became prominent. Why? Because there was code written in COBOL, and there were no COBOL programmers left. Okay, so they had to somehow, I guess, train people and get them fixing 40-year-old.
Jeff, I wrote a parser.
Yeah.
Which was going through transitive identification of the tape.
Yeah.
And therefore, we were able to change code fairly automatically.
Right.
Without understanding.
Yeah. All right. So 40 years from now, Python may be ancient history, but there'll still be code written in Python, and you'll have to maintain the Python environment and its compilers and stuff. Okay. Anyway, if I may, I just want to make a few comments about AI. They may not be the ones you expect. Okay, again, I'm an old guy. The interesting thing is my active career, which ended just sort of at the turn of the millennium. I was known as an AI skeptic. I was never hesitant to voice my contempt. And the reason I didn't like it was that my colleagues in AI were always promising and under-delivering. In particular, if you were doing anything but AI, you really had to struggle for resources. But if you were saying you're going to make computers think like human beings, and no matter how ridiculous and how far-fetched that sounds, especially the defense industry was willing to give you money because you didn't want anybody else to get ahead of us on machines that could actually think. And again, I feel that what they were doing, the fundamental mistake was that they thought AI was about imitating human thought. Okay. Tweety is a bird, but he's a penguin, so he can't fly. But he owns an airplane, so he can fly. But the airplane is broken, so he can't fly. Yeah, sure you can think that's human thought, but it's not really all that useful in practice. And I just want to make it clear that during that time, the AI community did produce some important software. I think, for example, Raj Reddy. Raj, I don't know. I probably insulted him at a time when I shouldn't, because unlike most of the AI that was going on, he solved the speech recognition problem by an algorithm that had very little, if anything, to do with simulating human thought. It just solved the problem. Another, I think, example is chess. John McCarthy was fond to say that chess was the Drosophila of AI. That is, it was the thing that just as biologists use Drosophila because they have this 3-week generation cycle, made experiments very easy. That chess was the thing that would guide the development of AI. It turned out when the problem was solved around 1995, a chess playing program could beat the world chess champion. The fact is that what's behind the Deep Blue, the program, was it did massive tree search, and it was able to do that because hardware was getting better and faster and bigger. And that's pretty much, well, I mean, there was obviously a little more to it, but that was basically it. Tree search is not an AI thing, it's just an algorithm.
Okay, then again, roughly at the turn of the millennium, I sort of, it became different. That is, people started to actually solve problems, and they viewed what they were doing as AI, just as Raj Reddy did, but they sort of forgot about mimicking thought, and just went out there and solved the problems. And of course, how were they successful? Part of it was the fact that the hardware it got way better. I mean, Moore's law sort of ended around the turn of the millennium, but but parallel hardware made it possible to keep throwing more and more hardware at a problem. With what you could do doubling every 2 years, and also just very, very large databases like the internet, for example, became available, and it was tractable. You had enough hardware that you could manage massive amounts of data. And what happens is, when you have enough data, machine learning will work even if it's not learning anything. So, I mean, what is machine learning today? It's you build a model of your data. Okay, very often it's a deep neural net, but it could be any of a number of other things. A random forest or something like that. Sometimes is a good choice. Okay, and then the LLM is probably the extreme example of this, in that it uses really the entire web as its data, and in this remarkable way manages to synthesize what's in the web in a way that you can use it and in, I think, very unexpected ways. Another example, the Japanese game Go. See, where chess may have a dozen different plausible moves in any situation, Go has hundreds of plausible moves. And so tree search doesn't work on Go even today. They needed to learn from data. There haven't been enough Go games ever recorded to do that. So the trick was they invented their own data. Okay, by just having the computer play Go against itself, and it did it, at astronomical speeds. So they eventually got the petabytes and petabytes that they needed to do a machine learning process. Okay, now it looks like everybody's. This is what I think I'm supposed to be talking about, is that what's happening to the industry of software development. Okay, now the first time I ever wrote a program, it was sort of in machine language. In fact, it wasn't even machine language. It was I had this computer. It was about the size of a refrigerator, but laid on its side, and you programmed it by sticking pins into holes. Okay, well, a year later, it was, I think 63, Fortran had just come out. And so I learned to program in Fortran. And of course, I was able to generate much more code much more quickly. Now, of course, everybody else also was able to generate more code quickly. So you might think that we needed fewer programmers. Well, in fact, we needed more. Why did we need more? Because so many more things became feasible and economically feasible to do with a computer, that the demand for programming far exceeded the gains in productivity that a high-level language gave you. Now, I see, the vibe coding as a similar jump in productivity. Okay, The trouble is, there are two questions where I think you'd like me to answer, but I don't know the answer, but I'll sort of lay out what the choices are. First of all, there's no question that there is difficulty getting jobs, first jobs in computer science. So here's, you know, I've heard that this is a fundamental sea change. I've also heard that it's a temporary problem caused not by vibe coding, but rather by overhiring during the COVID year. I don't know which is true. But let's say that vibe coding gives you a 2x improvement in speed. Does that mean we can do with half as many programmers as we have right now? Well, that might be true, or it might be true that twice as much code becomes economically feasible, and therefore it's a wash. Or it might be that 3 times as much code becomes economically feasible, and then we will in fact see a gain in programming. The other question out there is, really, are LLMs going to get any better? Okay. I mean, or are they already based on all the data that there is? Okay, it looks like there's nothing pretty much left on the internet for them to consume that they're not already consuming. Are there other sources of data out there? I don't know. You know, if not, then the only hope for improvements, you know, people talk about this artificial general intelligence, it'll have to come from something other than getting more data. It won't just be, this AGI won't just be a grown-up version of an LLM in some sense. Some people talk about creating synthetic data. Okay. I wonder, I don't think it's at all obvious that that synthetic data is, it will either lead you astray if the synthetic data is in some sense not representative of how people talk and think, or it will just be redundant in the sense that it's just saying the same old things again. Anyway, that's really all I have on it, and I guess I can take a few questions.
I had a question about sort of about research, particularly in empirical fields. So, in a world where it's easy to write a paper and easier still to fudge data, right? And so my question is about sort of the research industry, if you would, right? In a world where it's easy to write papers and potentially sort of manipulate data in a way to produce compelling results, and there is no countervailing incentive to review those papers, you don't get the same kind of benefits as a research career. What happens to publications and research and citations and all of that in a world with LLMs?
Boy, you know, you hit a raw nerve, because the only thing that I do really these days, except for the Datsu project, is I serve as an editor for a journal, and yeah, it's terrible to kind of get people willing to review papers. You know, I wish, frankly, that not every thought that pops into your head would turn into a paper. If people had a little bit of self-censorship, I mean, look, I got my first job without ever having published a single paper. In those days, it cost so much money. No graduate student had the money to pay for publication of a paper. I had to wait until I was at Bell Labs, and Bell Labs was willing to put the bill. People are putting much too much stock in publication count rather than publication value. And unfortunately, I have no way to, no idea how we might stop that from happening. One thing you can do, the administration of the university, is you can award tenure based not on the number of publications, but on, let's say, the quality of the best 10 papers. In other words, sort of discourage people from trying to milk milk publications out of their work. Just do the work. Eventually, you'll get something exciting, and then it might make sense to write a paper back. In my humble opinion, I understand it's not an easily solved.
Sir, I want to ask one question. Sir, you said about AI is more focused on the output, and it's the same algorithm what we are studying till date. My question is, what is your thinking regarding the cognitive computing? So whether is it the same?
You mean imitating human?
Yes,
thought?
yes.
Well, I think I had a bullet point that answers that question very specifically. I don't think that I don't think trying to imitate human thought is productive. Now, I should say there is something called neuromorphic computing. This is really a chip architecture, and it does have certain advantages for certain problems. Okay. But again, it has nothing to do with whether you're thinking like a human being. It's simply a question of, does your problem admit to having changes in very narrow parts of the chip at any one time? So most of the chip can sort of relax and not be consuming energy. Totally, people say it looks like neurons, but it's not thinking like a human being. It's just it's solving a real computer science problem, which is low energy computing.
Thank you, sir.
I mean, I don't want to take too much time. I just have like a bunch of questions actually. First question is, and it might hurt you a little, but since you have AI, do you need to learn compiler design and like systems level design and all that?
It doesn't hurt me in the slightest, and I know that you don't. Some people obviously need to know it, or you will never get a new programming language. But the time when compilers was the core required course, that went away probably before you were born.
And I'm still studying it, so I suppose it's still around. I had another question, which is really that you might have heard of AI-assisted research these days. Meaning researchers use AI to solve like a bunch of different problems, like say like the IDOS problem and all of that. What do you think about people, like instead of thinking, they offload the thinking process to AI to write research papers? Do you think that is like diluting the whole, the art of doing research, like how AI has already like diluted art forms and music and all of that? Is it something you're concerned about?
Not particularly. There's no question people will use AI as a research tool. But look, biologists use these knockout mice, as they're called, the genetically engineered mice, to solve problems in biology. That's a tool. And by the way, if you want to do that, you outsource it to China. You just tell them what gene you want. Knocked out, and they send you a box with 15 mice in it that have this genetics. It's a tool. it doesn't it doesn't prevent it doesn't take over the important job of the researcher, which is deciding which gene to knock out and why. But it's a tool. Similarly, if you can use an LLM to assist you, just as people have been using Google for a generation now. Right? If you want to do research, the first thing you do is you ask Google what's known.
I had like one last question, which is, I'm sorry, which is, you might have heard of like the singularity being discussed by many people like Jan LeCun and stuff.
Yeah.
Do you like, is it still in its infancy? Does it like concern you? Is it quite of a dangerous topic?
Well, when it doesn't concern me all that much. I know that that when the way they phrase it, once computers are both smarter than human beings and able to learn on their own, they'll become infinitely smarter. I don't think we're really there all that quickly. It's hard to say that would never occur. But I think it's a very outside chance to say that's going to happen this century. That's my guess. It's just a guess, obviously. I have no real command of the future.
Sir,
thank you.
Here's my question. It is about leadership in the world general. The people who have grown with AI technology advantage, what kind of future leaders can we expect? People who have been influenced too much by AI as against people who have never ever come across AI. So what do you think the future of political leadership will be? And what is the influence of AI in building these influence people in the leadership? In the political leadership.
Yeah, look, I know, for someone who's living in the Trump era, I certainly much prefer ChatGPT. No, ChatGPT, wouldn't invade Greenland, it would invade Microsoft. Yeah, I got no real answer to that. Just a joke, which you'll notice often substitutes for actual knowledge.
Excuse me. So what do you think about the Rust rewrites of most popular Unix Unix software? So do you think type safety is actually a thing that is required, or is it too much hand-holding for the programmers?
I have no knowledge of this. I haven't been dealing with that.
Okay. So I had a question. So in long term, which do you think will be, where will there be more demand for? Like AI-based developers or people who know low-level system languages and designs? Because even though like coding is becoming easier and more people can do it, but system design is still hard. So which do you think there's more demand for?
Well, I think it is quite possible that if there's job loss, it's going to be at the lower levels. And if that is the case, I really wonder what the industry looks like 20 years from now when all the senior people are retired and there are no junior people to replace them. Sort of system design is important. But remember, the real question is, what should we build? Then you hand that off to a system designer. Once you've decided, the top level person has decided what needs to be done, you hand that off to a system designer to build a system to make that happen. And the system designer then hands it off to coders. It could turn. It could be that we are having some distortions in the senior-junior level relationship. And I don't have any examples to really understand how that might go. Might turn out to be a problem long term.
Yes, sir. So, like in the sense, like now there might be like a struggle in like as you said, Moore's law was also there. Like so, they came up with parallel computation for that. So, do you think which limit do you think people will hit first, like the computation limit, or that we end up with excess of AI engineers, like people who can just code out platforms and build services?
Yeah, no, I don't. I don't think we're going to run out of low-level software engineers. What it looks like what would happen is it's going to become harder and harder to find people with the experience to take on the higher level functions. But again, I don't know. A lot of that has to do with the dynamics of how much more coding do we want done, if any.
Thank you, sir.
Good evening, sir. So my question was, in your age, learning or clarifying any doubts would have been done the hard way. So you would have had to refer many books in the library to even clarify a small doubt. But then in today's world, with the advent of LLMs, with just a simple prompt, we can just get the answer from GPT or any other LLMs. So I was thinking the advent of LLMs might have even hit a roadblock on cognitive development. So my question is, if you were a student in today's world, sir, so how would you use LLMs for learning or clarifying any doubts?
Okay, you mean let's say if I were taking okay, I think what you're asking is, okay, I'm taking a class in compilers, let's say, and I don't understand something. So I go to an LLM to ask for an explanation. I actually do that a lot anyway. My job as an editor, I have to handle a paper on a subject I know nothing about. And so basically, I go to a Gemini or something, and I ask it, what does this mean? I think, again, I'm doing it now. You're probably doing it now. If I were your age, I'd still be doing it now, but a different set of problems. There's nothing wrong with that. Again. For 25 years I've been Googling stuff when I didn't understand it.
So my main question was, before the advent of LLMs, we would have to read several related concepts and try to connect the dots to arrive at an answer. But now with LLMs, it does all the thinking for us and it just presents the answer for us. So do you think that has impacted our cognitive function, and would we have to think of an innovative method to use LLMs for thinking?
But first of all, before there were LLMs, there was Wikipedia. That was the one source you went to learn learn about a topic. So I don't think that Wikipedia has made us stupid, if that's what you're really dealing with. So I don't think an LLM use will make us stupid either. It may, you may have less practice in, let's say, synthesizing, connecting dots, as you say. But on the other hand, the dots will be connected for you, so it becomes a less important function, I guess.
Professor, I actually have one question for you. Is it true that you have a flight to catch today?
Yes, that is true.
Okay, so I think in the interest of time, we won't be able to take any more questions. But I think We need a round of applause. Maybe two for this session. Thank you so much, Professor, from the bottom of all our hearts. And to formally conclude the proceedings, I invite Ms. Sanjana Rangan to propose the vote of thanks.
I won't take too much of everybody's time because we had a wonderful discussion and there's a lot to take in. But formally, I would like to thank everyone here today. So on behalf of Prayoga Institute of Education Research, I extend my sincere thanks to everyone who is committed to making this program a huge success. We're grateful to RV College of Engineering and the Rashtriya Shikshana Samiti Trust for graciously hosting this event and for our partnership. Our thanks to Dr. M.P. Shyam, President of the RSST, and Dr. K.N. Subramanya, Principal, RVCE, for their leadership and support, and to the faculty and administrative teams at RVCE for their meticulous coordination. Thank you very much. I would like to acknowledge the leadership at Prayoga who are here today. Dr. H.S. Nagaraja, Founder and Chief Mentor of Prayoga, whose vision continues to guide our institution's work. And Dr. K.S. Nagabhushana, Director of Research at Prayoga, for his academic stewardship and contributions to our research initiatives. We place on record a very special appreciation to Shri D.N. Prasad sir, founder of Surya Software Systems Private Limited, whose initiative brought Prayoga and Professor Ullman together, a connection that's been instrumental in building the Dhatu program at Prayoga. And a sincere thanks to Professor Jeffrey Ullman for a very engaging conversation and sharing his insights so openly with a lot of humor with all of us. We're grateful to Dr. K. Subramanya and Mr. Sumukha for moderating that fireside session, and to Ms. Mrida for anchoring our program with grace. Our thanks to our industry colleagues, the academia present here, the CSR partners and foundations that have supported both institutions, and obviously the students and very interesting questions that really made today's event. Thank you all so much for being here today, and we look forward to seeing you after the event.
Rida, are you going to say something?
Sit down.
We would now like to facilitate our guest of honor with a small token of our gratitude. Another round of applause, please.
Thank you.